Hello? Mm. Okay, so good morning, everyone. Let's start our second lecture. And this lecture will be there will be two parts. The first part will be about how we deal with data in a real-world data set. And the second part will be something related to optimization. And I've already uploaded the lecture notes in the OLE. So if you cannot see clearly in the screen here, you might open it with your own screen. And yeah, and before we start, I like to talk about the assignments. So some of you maybe already have your lab this week. And the lab this week required submission. And as I've told you last week, so each of the assignment will take 1% actually. So in total, you have 10 assignments, and each of it will take 1% of your final score. And so usually I will give you like a week to finish your assignment. And for example, if your lab is on Tuesday, then your deadline of submission should be the Monday next week. But due to the Spring Festival, so we will have a holiday, right? So I don't want to make you doing assignment or submission during the holiday. So we will postpone the first deadline to the week after the Spring Festival. And I will upload this kind of assignments in the OLE, I mean the submission link in the OLE later. And okay, so that's it. And and I also want to talk about the criterion of the marking. So as you know, each assignment take only 1% of your final score. So I will give you like 1 mark if you submit it on time and you've done the things. And if you have late submission, your mark will be deduced 20% per day. And if you didn't submit any assignment for each assignment, then you have 0. And the point here is that for every single lab, we will check only 5 assignments randomly. So I mean, we'll get 5 assignments from each lab. I mean, like we will check the assignment for 5 people in each lab. So it's like random. And so the point is like you still need to do it. And just in case that you are not lucky that we sampled your assignment, and if you haven't do the things, then you have 0, even you submit it on time. So this is the point here. And okay, any questions regarding the assignments? If no, then let's start our lecture today. Yeah, so today we are going to talk about the most important part, the data. So as I've told you last week, that machine learning is a data-driven model. So the data is the most important part in the whole workflow. And these days, you might have like two different ways for you to collect data. One is to get the online data in some open source websites. And then another way is to collect the samples or the data set by yourself. And here I can give you some example. Let's see. For example, maybe you've heard about Kaggle. Yeah, here. So this is an open source dataset website. And you can find different kinds of dataset here. For example, fruits here. And some of them might include code inside. So these are the example code that you can use. So they include the whole workflow of from data processing, feature extraction to this is just like to how to use this data to import the data. Okay, and then some of them have like the whole workflow. Even they have the trained model inside the data set in the code tab. And yeah, so this is one of them. And sometimes if you read paper, you have read paper, I mean, some journal paper or conference paper, you might find that people, they will upload their whole project on the GitHub or some other repository. So you can also use their link to access to their whole project of the code and also the data set if you want to reproduce their results that they publish in a journal. Yeah, so this is how you do other kind of research. Okay. Yeah, so if you haven't taken attendance, you can still take your attendance here. Okay, then let's keep on our lecture note. So last week, we've talked about the machine learning workflow. Usually you will have some historical data. So that could be downloaded from the internet or you collect them by yourself. And then you use this kind of historical data to train your model, or we say to do the modeling here. And the first step is like to build your model and train the model with the historical data. And then you do the model evaluation. According to the result of the evaluation, you can do model optimization to optimize the parameter or the structure of the model, and then to do the evaluation again. So it's like kind of loop. And when you're satisfied with your model, then you can deploy your model in some application to predict on new data. And finally, you have some answers for the result. I mean, the answers of the predictions. Then you can check the performance of your model in the real time, sorry, in the real world problem. And here, I also want to mention one thing. So usually here, let's see. Let me try to use the pen here. So this historical data is the data you used when you are training or build up your model. Usually you will split this data set into a different subset, okay? So let's say you split it into two subsets. For example, you take 70% of data to train the model, and then 30% of the data to do the model evaluation. And here, that means the historical data set can be split into a training data set. So here we call it training data set. Doesn't matter. Okay, training data set. and then evaluation dataset. And this evaluation dataset, sometimes we also call it validation dataset. And after you finish your modeling, you are doing prediction, then this new data here, we usually refer it to test dataset. So what the point here is that you should always keep in your mind that when you are doing a machine learning job, for each task, you should have three kinds of data sets: the training data set, the validation data set, and the test data set. And the training data set is used to train the model. The validation data set is to validate your model. And it enables you to optimize your model. And after you finish the modeling of your model, then you can test your model on the test data set, which is from the new data. So it is not existing in your historical data. And another point here is that you cannot use the test data set when you are doing modeling. So this is a kind of leakage of the future information. So that's why in your final mini project in this course, I will only give you the training data set and the validation data set. So I will not give you the test data set. And the test data set, I will, do test on your model by myself to see the performance in case that you will train your model with the test data. Okay, yeah, that's about the data set. And then we can have an example here, like churn prediction, or we say 客户流失预测. So churn prediction means to predict the act of a customer canceling or unsubscribing from a paid service. And let's take some business company as an example. And these kind of business companies might want to know which of their customer will churn this month. Or like if their customer will click their advertisement. And like if the user account is a fraudulent account. And also if some customer or the users post some tweet in the website, they want to know if the sentiment of the tweet is negative, positive, or neutral. And yeah, something like they may also want to know like what will the demand be for their product maybe next month. And have the first glance on these questions, you might find they are quite different, but actually they have quite a lot commonalities in these questions. So they are all making assessments on one or several instances of interest. Here. And for example, in the first question, the company want to know if the customer will churn or not. And also in the second question, the company want to know if the customer will click the advertisement or not. So this is like they are making assessment on several or one instance of interest. So they has a well-defined target. And because once you download the apps or you are using their service, the first time you are using their service, they start to collect your data. That's why they have a set of historical data in all these questions. So this historical data enable them to predict your future behavior. And also another thing here, the commonality here is that there always be an implied action if the target were knowable. So for example, in the first question, if they know that a customer is going to churn or unsubscribe this month, they might give you some discount or promotions. And also, if you post some tweet with negative sentiment, then some related department will respond immediately to your tweet to justify or just help you to solve your problem and keep their official profile. Yeah, so once they predict the outcome of these questions, they can take some actions related to the questions. And then let's have a look at the data set in this example. So let's take a telecom company as an example. So like the telecom company want to predict which of their cell phone subscriber will unsubscribe in the next month. And here's the data set. So we can see there are a lot of features here. So we've talked about features last week. Feature means the information related to the target. And target means the one you want, the kind of label you want to predict for your machine learning task. So in this case, they want to predict if a subscriber will unsubscribe in the next month. So this like true means they will subscribe. True means they will unsubscribe. False means they will keep subscribing. And then we have features here, and each customer represents for a certain example, or we see instance here. So these instances are used as a training data set. We can have a look at the features here, like the customer ID, the state. So the state here actually means, because this data set is example from USA, so state means the location or the state they live. And account length here means how long they've used their account, how long they've held their account, and some area code about their location, and like international plan, if they subscribe the international plan or not, and like if they are using the voicemail plan service, and what kind of, what the total message they send every month, and the total minutes or total calls they have. And these are all the features they might use when they do training. So yeah, you can see that we have a lot of features here, but which input features should we include? And how much training data do I need? So of course, sometimes we'll not use all the features here, and here we only have 4 examples. So of course, it is not enough data set. And some of the features are not useful. So we need to select the features when we are doing machine learning tasks. And also we need to define, or we need to test what's the training data set, the size of training data set we need. So the rule here is that features that obviously have nothing to do with the target should be excluded, because the more uninformative features are present, the less accurate the machine learning model will be. So if you present too much useless information, and then because the model don't know that if this information is useful or not at the beginning, and they might treat this information as useful to make decision. Yeah, so for example, in this set of features, which one do you think is the most useless? So from my point of view, of course, it's the customer ID, because customer ID is just some random number assigned by the telecom company, and it does not relate to the subscription. And like the most important one might be the total minutes or total calls, this kind of things related to their service. So because once you use their service very frequently, of course, you will keep subscribing their service. So this is like the importance of different features that you might to pay attention when you are selecting them. And of course, later you will learn some machine learning techniques to decide these kind of features automatically. But at the beginning, you should know this kind of different importance of different features. Okay, then let's talk about how much training data we need. So it's quite depend on the complexity of the problem. Like the relationship between the input features and the target variable. So for example, if you want to predict just like how long a train will arrive, once you know the distance between the two locations and the speed of the train, then you don't even need to use the machine learning model to predict how long the train will arrive. But like in our previous example, it's not intuitive that which feature is related to the target. So it's hard to decide a single function that you can map these features to the target. So this problem will be much more complex. That's why you might need more data. And also it depends on the requirements of the accuracy you want. So if you just want to to train a rough model, then you can use less data sets. But if you want to get a very good accuracy, like in your final project, you might to collect more data. And also, it depends on the dimensionality of the feature space. So of course, more input features we have, the model will be more complicated. It's just like, I don't know if you've learned about this kind of multivariable calculus. And then, you know, or even just in math, in the equations that you want to solve. When there are more variables in the equation, if there are more variables in the equation, then it will be more difficult for you to solve this kind of problem. So it's the same thing in machine learning. If you have more input, then the model will be more complex. Okay, then let's have a look at this kind of example. So let's see on the left side, you have a plotting here. So this is the relationship between the performance of the model and the number of training instance or training examples we use. So here we use the accuracy as the performance matrix. But I mean, this is just an example. Sometimes you might use other performance matrix. So here, this time we use accuracy here. Actually, this is the most common. Sorry, this is the most common thing here. And then what you need to do is to choose a grid of subsample sizes to try the performance of the model at the beginning. So let's say you can try different sample sizes. Start from 250, and you might get accuracy of 86. So 86%, always 0.86. And then you increase the training instance, or you increase the scale of the data set to 500. Then you might have like 90% accuracy. So you saw a big change or a big improvement when you increase the data set. Then you just keep increasing the samples, number of samples. Here, you plot a curve here. And in the end, you find that the performance does not improve anymore when you increase the number of samples in the training data set. So that means the training data set, the samples in your training data set is sufficient. Yeah, and yeah, this is the overview, but let's break it down to the steps here. So in the second step, you should randomly draw the instance for each sample size. So like you want to take 250 samples from the whole data set to train the model. But which 250 samples you should use. You cannot select subjectively by yourself. Usually you need to do a random choice to do the task in a more objective way, preventing from inducing bias to your task. And then for example, you randomly choose 250 samples. You might get an accuracy of here like 83%. Then you will repeat this procedure. You will take another 250 samples because depends on the samples you choose. The model might have different performance. That's why you need to choose multiple times with different samples, but the same sample size. And then you will have several points here. For example, the best performance you get may be 89%, and the worst you got is like 83. Then you just take an average of them. So this will be the final accuracy in this step of 250 samples. Then you just do all the things again and again. You increase the sample size to 500, and then create some data set with a random sampling strategy to collect like several subsamples with 500 data set inside, and then you evaluate, you train the model again to check the performance. You got the average performance here, and then you can plot this whole curve as you increase the sample size. Yeah, and then in the end, you may find that the accuracy sometimes increase, sometimes decrease. So it means you have sufficient data set in a training data set. And you might have some questions here that why you don't directly use a very large data set. For example, you directly use 4,000 data in the first step. So that means you don't need to check like what is the most proper size of data set. Okay, so the point here is that when you are doing machine learning tasks, you want to train the model in a more efficient way because you need to frequently adjust the parameter and the structure of the model to see the performance of the model. And then you might, let's go back to the workflow. So you will do this modeling in a loop for many times, maybe 10, 20 times. And then if you are using a very large data set at the beginning, then let's say you have a competitor. So you are working in a company and you have a competitor. Your boss told you that who finish the task first will be promoted. And then you are using a very big data set, which costs you like 10 days to train one time. And then your competitor, because he select a very proper size of data set, he find out that 10% of the data is already enough to evaluate the model. Then maybe he can train the model in 1 day. And then when you evaluate the model for one time, he already evaluated model with 10 different structures. So he is working in a more efficient way than you. So that's the point. Then maybe your boss will choose your competitor because he is more efficient. He can finish the task faster with better parameters and the structure of the model. Yeah, so this is the point why we need to decide a proper size of the training data we use. Okay, then let's talk about data preprocessing. Yeah, so let's take this Titanic passengers example. So we can see there are a lot of features here. And some of them are numerical numbers. Some of them are like text. Actually, so all these things are, with the arrows here are the categorical features. So this means the value of the feature is a category. And except categorical features, we also have numerical features like the fares here and the age here. And then you might have a question here that why this like P class, it is written in numbers, and also the survived class, feature is also written in numbers. Why they are called categorical features? Because actually they are still present for a single category. Like let's take P class as an example. You have like first class, second class, third class, but you will not have a 2.5 class, right? So it means this categorical data is usually discrete. So if you put 2.5 here, then we don't know what's your meaning. And it's like also like for survived, 0 just means the passenger is survived. Oh, sorry, is dead. 1 means the passenger is survived. So you cannot like put 0.5 here to represent something like between dead or survived, or maybe missing, but you can give another category. You can give 2 here, right? And like the different thing here is like the fear. So you can have continuous number here. So each, like you can have a lot of decimal points here. It still have its physical meanings here. And also like for ages. So usually we present your age like by 22, 23. But if you say you are 22.5 years old, it still makes sense. Maybe you just like passed half year of your 22nd year. So what I mean here is that all the numbers in a numerical feature should be continuous. So any number inside this range will have its physical meaning. But in categorical data, even you represent it by a number, it is a discrete number. So some numbers, it doesn't have physical meaning when you put like some numbers between the interval. Yeah, so this is a point here. And maybe I can explain it again in Chinese. So like 类别的特征就一般是离散的，你可以用一些，虽然你可以用数字表示，但是你不能说你用 1.5 去表示另一个类别。然后那个数字的特征呢，它是连续的，所以你可以用任意值表示一个任意值表示它的特征，所以它是连续的，一个是离散的，一个是连续的。And so because we've talked about it last week, that the machine can only understand numbers. They cannot understand text. So how we deal with these text things or the categories here? So here we use a technology called one-hot encoding, 读热编码. So to be more specific, let's take example of the gender here. So we have 2 categories in the gender, the male and the female. So when you want to encode, so encode means 编码. So when you want to encode this gender to make the computer or the machine understand your input data, you should encode them into numbers. So in this one-hot encoding, it means you will give the same numbers of 1 and 0 according to the number of categories you have. So let's say we have 2 categories here, male and female. So in this encoding, we will have only 2 columns. Each column represents for one category inside. And then we just compare the category and the data you have. So if the data you have is the same as the category, then you put 1 here. And if the data you have is different with the category, then you have 0 here. So to represent the male here, you can use 1 and 0. And when you want to represent the female here, you use 0 and 1. And also, if you have another features, so you will have another column here. Okay. And let's say there's another category. Okay, so trans. You know what is trans, right? So trans means 人妖. Okay, so let's say we have another gender, trans. Okay, so you have another category here. Oh, I can use the pen here. Okay, then for the male here, you will put 0 here. Wait. Okay, doesn't matter. Okay, for the male here, you will put, for the male here, you will put 0, okay? And for the female, you also put 0. And for the trans here, you will put 0 in male, 0 in females, and 1 in trans. So that means when you have 3 categories, male will be represented as 100, female will be represented as 010, and trans will be represented as 001. Okay, and then here is a typical code that you can use to convert the categorical features into a numerical binary features. So usually we use this unique function. So this unique function find all the unique features or categories, all the unique categories inside your data. So for example, here it can find 3 different kinds of unique categories: the male, the female, and the trans. And then for each category in these categories, so here this cat doesn't mean the creator cat, okay? It's not the puppy. No, puppy is what? Okay, doesn't matter. It's not the animal, okay? It's the category. It means the category. So when you are writing this code, when you are using this code, it check if your data is equal to the category here. So if it is equal, then it put 1 here. If it is not equal, then it put 0, false, true or false. And then for all these for each category in these categories, you just check all the categories and then append the final result together to get one hot coding. And okay, so this is the final result of this one hot coding for the categorical feature. Okay, then let's talk about how to deal with missing data. So you can see that in this example, some of the information in the table is missing. Let's say the age of a certain passenger, and then like the cabin they stayed in on the Titanic. And because, they are dead, so you are not able to ask them again, like, what's your age? So it means the data is totally missing. Then what you should do about this missing data. So firstly, you should check if this missing data is important or not. So does it have real meaning, like in your project or in your task? So if this useless, then you can just eliminate the missing values. Or you can replace them by some guessing value, or we call imputation. Okay. And we'll talk about it later. And so then if this is useful, and you can also have two kind of options. Firstly, if this is a numerical data, so you can convert this missing value to some meaningful numbers, like -1, -999, just to use them as a placeholder to in case that the feature is empty. Okay, and then also you can create a new category for these missing values. So let's see here. Let's take this gender again. So if there are some genders missing, the information is missing, then you can create a new category of missing here. You can create a new category of missing here. And then you just need to add one column here. So each of the data will have one more bits to represent for the whole encoding result. Yeah, so this is another way that you just create a new category for the missing values or for the missing samples. Okay. Then when you, sometimes even the data is not that meaningful, but you might lose a lot of data in the data set. Let's say you've lost like 20%, or so let's say 50%, half of the data set of the cabin. Okay, then to create, you cannot just eliminate all the instance or the samples here, because if you eliminate all these samples, then you only have like 50% of sample data set left. Then it will damage the performance of a model, because maybe the data set is not enough anymore. So what you can do here? So yeah, so as I've talked about here, if only a little data missing, you can just remove the instance with data. And if the data set is a temporal data set, so it's related to a time, then you can really replace the value with a predicting instance. So let's see, we are doing like temperature forecasting, and we have a curve of the historical temperature. So the trend something will be like this, right? And then let's say this part of the data is missing. So what you can do? You can just using some machine learning method, or just insert some values, which is like the average between these 2 points, or you do interpolation to add the data by yourself here to create a curve that mimicking the real part. So this is like how you deal with the temporal data. And also, otherwise, you can check if the model follows a simple distribution. So let's say if the let's say the age. So you know that the age usually will follow a normal distribution. So you can just insert the age of the missing item according to the normal distribution. And then if it does not follow a simple distribution, then you can also use some machine learning model to predict this value. So what you can do here is that you use other features again to train another model to predict, to use this like age as a target. And then you use other informations to predict this age. And after you use this model, the first model to predict this age, then you have a full data set. I mean, all the data will be fulfilled for your future task. Then you use this full data set to predict, to predict the survive again for the real task. So this is like you need to train 2 different machine learning models One is to predict the missing value. Another is to predict your real task. Okay, and then this is also called imputation. Okay, then let's talk about data normalization. Yeah, so because the value range of a feature can influence the importance of the feature compared to other features. So this, we will talk about it later in the optimization part again. Okay, so normalization is like you normalize the data into a range from 0 to 1, or from -1 to 1. And here is a simple normalization function that you just get the maximum number of the feature, the minimum number of the feature, and then you calculate the normalization factor based on the maximum value and the mean value, and then normalize all the data according to this factor. Okay, then the range of the data will be normalized to 0 and 1. And the point here is that let's take this, the data is too messy, so let's just, if I can remove all the things here. Yeah, so let's take this data set again. So we can see here we have categorical data and numerical data. And so the categorical data, when we encode them into number, for example, the gender, it will be 0 and 1, right? So it's a very small number. But if we are doing machine learning, and then we have some other features like age, so it will be like, for example, this point here, 38. So this value is much bigger than this value here. And then because of the difference in the magnitude, the machine learning model will treat this feature as more important. And then we will talk about it later in the optimization, like why the machine learning model will treat this high value is more important. Okay, so don't need to worry. And okay, then this is the first part of this lecture. And there are some terminologies. Yeah, so like the dummy variables, it's like a binary feature that indicate an observation that is a member of a category. Yeah, and then the ground truth is the value of non-target variable or label for a training data set, training or test set. So this is the label of the real label of each sample is called the ground truth. And then missing data means the data that you missed in the data set, and imputation means that you replace the unknown values of the missing data with a numerical or categorical value. Okay, yeah, so this is the end of the first part of this class, and you can have a 10 minutes break, and we will talk about optimization after your break. Thank you very much.
就是我到这已经开始有点懵了，就是这个是解，这个是这个代码弄出来的结果。
对，
然后那可是它一代表什么？代表什么？
一就代表就是这个 category，是属于这个 category，因为就比方说你有多个 category，比方说我刚不举了一个例子嘛，你可以有三个 category，然后比方说你有三个 category，你就多加一个零，就一。就最后一个结果是什么呢？就是你不管你有多少 category，它总是可以表达成一串零和一的那个组合，100、010和001。对，然后至于你是用100去表示 male 还是010去表示 female，这个其实是无所谓的，它只是一个，所以这个就是那个 dummy variable，就无所谓的，它只是一个表示方法，就是让计算机可以理解你这个输入是什么东西，就理解它们的不同，然后你只要自己知道这个每个001或者010代表什么东西就可以了。
那然后这个代码它有 data 是，我没看懂它 unit 这个分数是拿来干嘛
Unix 是这样子的，就比方说你这里总共有两种两个类别的 category，对吧？然后它就会去一个一个比，比方说它和这个是相同的，那它就不会把这个做成 category，所以它只会找出那个 unique 的 category。
说我们输入的时候不是一个 table，
对，所以这个是你的 data 就是
它只是
这个，
我以为
这个是
它输入
data，
的是一个
这个是 data，你整个 list 是一个 data。然后呢，它先在你这个 data 里面找出可能存在的 category，比方这边它找到两个 category，然后它再拿这个 category 和你那个 gender 去比，然后它比方说和你这个 gender 比一下，这 cat 就是指那个有这 category 里面的东西。
可是它 data 的话，它 data 现在是这个嘛？然后它就会它是每一行对比，这是 male，第一次对比的话就是 male 对
male，对，它是拿这个 cat 就是这个 cat 是什么意思啊？cat 就是指 male 和 female，就是 category。然后它只有两个 category 嘛，它做个循环嘛，它对两个 category 分别对这个 data 进行变异，对吧？
对 ，OK，
对，然后就比一下比一下，就这样子。对，其实真的你做的时候，应该是我反正是没有用过这个代码，我一般都是直接手动给它编一下，就你直接把这一行 column，比方说这个是 male 的，你直接就变成1，不是 male 就变0。
对，它数据应该会很大吧？
对，然后还有一个方法，这边你可以把它先编成1和2，然后你用1和2，再让它去用二进制表示，对吧？就比方123，然后你再去让它再让它用那个，你再把那个改成，比方说01，比方说你知道有3个类别了嘛，改成001，二改成010，三改成100，也行，不一定要用这个方法。就是最终的结果就是你做一个 one hot coding，就最后表示成0和1的一个那个。
我理解，
对编码后的那个。
然后我有一个问题，就是为什么 missing data 我们还需要继续去搞它？就是我觉得 missing data 没有用，那就不用理它就好了。如果是没有用的话，
这个是这样子的，比方说我刚刚就说，你比方说你这里，比方说啊，它这里总共就6个 instance，6个 example，对吧？你有4个是 missing，然后你把它们4个全去除，那你是不是只剩2个？
那直接这个
sample？
column 去除了就行，不是吗？
对，这个 column 去除也是可以的，但是
那就不用管了呀。
但是你也还有别的 column 的。
可是如果这个 column 不重要的话，就是不会影响数值，就是
对
machine learning 的话，那你就是它 training data 的话，那就可以不用这个 column。
对，这个 column 你可以直接把这个 column 去掉。但比方说你还会有别的那个别的那个别的那个可能有用的，或者就它可能不是只说这个地方 missing，也有可能有别的地方 missing，对吧？然后就比方说你想呃对，然后你想那个人就使用这些数据的话，你可能可以那个 就是做个 imputation，其实这个无所谓的。讲道理，这个就 lecture 说，实际上我是不会去做 imputation。就你要这样做，所以
其实这真实的话，就是这一行其实如果是没有意义的话，就不用管它了。
对，如果像这种对于 colon 的话，其实是你可以直接删掉，但到时候你自己实际做项目的时候，你有时候会碰到一些更复杂的一些场景，然后那种场景下你可能是需要做 imputation 的，尤其是那种时序的问题。对，就到时候你遇到了之后，你可能就会理解为什么要那个，但直接这样说的可能就不太好。
然后这个就是在讲这个，不对，在讲哪个这个
normalization。
然后我也没看懂为什么公式要这样子。
这个就公式把它弄得很复杂，然后可以给你就搞个很简单的，比方说你有一些点，对吧？你有一些点，
就是取命啊，取命就是
没有取命是那个另外一个叫 zero score， 这个叫 standardization， 那个标准化。那个叫标准化吗？那个叫什么？我不知道中文什么意思。这个是 normalization。最简单的是你，比方说一个零和，比方说它在那个，
它字是另外一页，所以你要往上滑一点。
OK， 就比方说，是零和一，零和这个，比方坐标轴从0开始，对吧？你有个这样一个 curve，你怎么去做 normalization 呢？你取一个最大值，对吧？一个最大值，把所有的值都除以这个最大值，那不就把它变成0和1之间了吗？对吧？那如果你这里有个 offset 呢？为什么你这里有个 mean value 呢？就是防止你这边有个 offset。比如说你这个 curve 可能不是从边开始，可能是这样子，对吧？然后你就要取这边的距离，最大值和最小值，用这一段做一个 factor 去 normalize 这边的值，然后再加上那个最小值，就是它最终的值。这个也叫最小值，我感觉应该不用讲。其实昨天我也没看。
然后那这个的话是拿来处理什么？
就是就有一些
为什么要这样做？
按照比方说你这个有2种不同的 feature， 对吧？一个是 age， 一个是 male。male 你不是把它编码成0和1吗？age 但是它数字很大，40。那你比方说一个输入是一个输入40，那你随便做一个 function， 那肯定是40对这个 function 的影响更大，对吧？那么现在你就会觉得，这个数字好像对我这个 function 没什么影响，他就可能就会去忽略这个，它占比会更重，这个占比会更小。那我们肯定是不希望遇到这种情况，我们肯定是希望它 fairly treat all the feature， 就是公平的对待所有的那个 input， 对吧？不能说人为的做一些干扰，去那个影响它。所以我们要把它所有的 data normalize 到相同的 scale 中间去比较。
OK，我理解了。
我到时候做 normalization 做 optimization 的时候还会有一些。OK，
Then let's start our second part of the lecture. So we know that, what actually machine learning is doing. So actually machine learning is just doing optimization of a function. So it wants to optimize this function to map your input to your output in a better way. So that's what we need to know about optimization in this part. And yeah, so we'll first talk about what is optimization, and also we'll talk about some terminology and notations in this topic. So what is optimization? And in optimization, we are always trying to find the best solution, like the cheapest, the fastest, or the shortest option. And then sometimes there are no constraints, and we can find the best solution without any rules. And this is called unconstrained optimization. And sometimes we'll have some constraint, or I would say at least one constraint. So it means this is a constraint optimization problem. And we can look at the example here. For example, you want to find the cheapest flight from Hong Kong to London. Then this is a very simple unconstrained optimization problem. And you just need to look at the price column of the list and find out the cheapest price of the flight. And when we add a condition here that we want to find the cheapest flight from Hong Kong to London, which will take off at night, then you might need to add a filter on the list. And then find the items of the flight in the night to choose the cheapest, and then choose the cheapest one. Okay, and then we have another problem, which might be more complicated, to find the route distance, to minimize the route distance from Yuanlang to Cologne. So I think it's Cologne, right? And so we know that usually the shortest distance is the displacement or the straight line from the two locations. And this is always the thing that the first time you search the distance from two locations on the Google map, they will usually give you the displacement, always the straight line from the two locations. But usually you will know that this straight line doesn't represent the true distance of the route that you will pass during your trip. And this is a kind of constraint. So let's say if you want to take a taxi from Yuanlang to Cologne. Yeah, so it is Cologne, right? And anyone know Cantonese here? And so then you know there are some roads that they only have one direction, and some pathway they might not allow the taxi to drive. So these are all the constraints that you might have when you are trying to find the shortest route or minimize the route distance from the two places. And in this example, so the objective function, let's talk about some terminology to make it looks more professional. So like the objective function in this case, fx is the example here to minimize the distance from two places. So this is called the objective function. This is the object. And this is the output we are trying to minimize. And x is a variable. This is the input of this objective function, and it is the thing that we can control. So, when we are going from Yuanlang to Cologne, maybe, at the beginning, or some idiot might go to the island first, and then he will go to Cologne from the island sorry, yeah, front island. So then the distance will be much longer. And so that's what I mean. The distance is the thing that you can control, depend the ways you choose to go. So yeah, so this is called a variable. It means the variable that you can control. And ideally, the route distance, as I've just mentioned, should be the displacement between the two places. However, the constraint imposes a limitation to the problem. So because I think it's not like everyone has a helicopter that you can directly from Yuanlang to Cologne. So usually you cannot treat this displacement as a solution for the road distance. And that's why we need to choose some other routes. So let's say if we want to buy a taxi, sorry, if we want to go to Cologne by taxi, then it's another constraint. And we have two kind of constraint here actually. So one is hx and another is the gx. So the hx means the equality constraints. So for example, in this case, the constraint should be equal to something. Let's say the type of vehicle you are choosing is equal to taxi. So this is a equality constraints. And we also have something called inequality constraints. Let's say if you want to put the constraints that you want to control the total price of your trip under a certain threshold, let's say 200 Hong Kong dollars, then it will be a range. The price will be a range from 0 to 200. So this is inequality constraints. Okay, then we can also formulate these kind of things in a mathematical way. Let's see. We have a objective function, and then we want to minimize the objective function based on the control of x, and the x is subject to some conditions here, hx and gx. So this is the formulation of the optimization problem. Yeah, so usually nowadays we do optimization with some library in the Python. So you actually don't need to do optimization by yourself. So you don't need to worry about these kind of mathematical things. Usually we just use the optimizer designed by others because it's already very mature. So you don't need to develop your own optimizer. And in your network, usually we only use the Atom optimizer, and we will introduce it in the later courses, I think. Okay, so then let's have a look at some example about optimization. Yeah, and this is a very simple example that you want to find the minimum point of a curve of a function, which is x squared plus 1. And then we have a constraint here that the x should be between -5 and 5. So usually how we find this minimum point? Anyone still remember the solution from your high school maybe? Or the first year of your undergraduate? Yeah, I think it should be the calculus, right? Math calculus. How you find the minimum point of a function. So usually we just calculate the derivatives of this function. So we know that, let me try to write here. We know that the derivatives of fx equal to x squared plus 1. And then the derivatives of this function should be 2x, right? And so if we want to know the minimum point or the maximum point of this function, then we just to put this equal to 0. Then we can solve it that x equal to 0. So that means the point x equal to 0 is the minimum or maximum point of this curve. And then how we decide like which, because we know this is a maximum or minimum point, but we don't exactly know if this is a minimum or maximum. So how we know if this is minimum or maximum? If you still remember that we should calculate the second derivative of this function. So we calculate, so the second derivative of function. So now the function become fx equal to 2x, right? And the second derivative should be fx. This is the first derivative. So the second derivative should be equal to 2. Okay. So then we just put this point 0 inside this second derivative. So actually, it doesn't matter in this case. We put this point of 0 inside in these second derivatives, and then we still get the number of 2. And because it is a positive number, so it means this is the minimum point of this curve. And once it is a negative value, then it means it's the maximum point. Yeah, so I don't know if you still remember, like, what's the physical meaning of the let's see, what's the physical meaning of the first derivative equal to 0? So it means for each curve, the slope at this point should be 0. Right? Sorry, my drawing is too terrible. Okay, let's say we have a curve here. So when we see the first derivative equal to 0, it means the slope is 0, like this. Okay, and then we can also sometimes have curve like this. So we don't know if this maximum number or the minimum number. That's why we need to calculate the second derivative here to decide if this minimum number or maximum number. Yeah, so this is a simple example how you find the minimum or maximum number of a function. Yeah, and so sometimes you might have multi-variables. Okay. So and the method you use here to find the minimum and maximum point here is called multivariable calculus, right? I don't know if you have already learned, but the symbol will be like this. And so it will be like this. Fx. So always say this is partial derivatives. For example, the partial derivatives of x1 is like this. So this is how you calculate the minimum and maximum value for a multivariable function. Yeah, and then you calculate both x1 and x2, you will have a point of x1, x2. In this case, it will be 2 and 2. Yeah, so because the So we have a constraint here that the x1 should be bigger than 2 and x2 should also be bigger than 2. So the minimum number should be 4. And in this part, I also want to mention again about the normalization here. So in this normalization, when we're talking about is to solve the different scales between different features, because sometimes the feature have a large value, sometimes the features have a small value. And this is like the point here. Let's use a function as an example. So let's say we have one function called y equal to x squared plus 2 x1 squared plus 2 x1 squared plus x2 squared. So this x1 represent for one feature and x2 represent for another feature. And when we are trying to find the minimum or maximum point here, we do the derivatives of it. And then we get this equal to 2x1 plus 2x2, right? And then think about the problem here. If you have two features with different scale, one feature is from 0 to 1. Another feature, you have values, maybe from, let's say, 1,000 to like 10,000, okay? 1,000, 10,000. Then what's the value of this first derivative will be? This value will almost the same as 2x2. Because compared with x2, s1 is too small. And then when this neural network or this machine learning model is doing optimization, it will feel that x1 is useless because no matter how you adjust this value of x1, it has almost no influence to the result of this function. That's why the machine learning model will ignore the changes in your first feature and then focus on the adjustment of the second feature, which is much bigger. So this is why we need to do normalization to put them in the same range of values. Or the bigger value of features will take more weight. 就是比方说你的两个输入的特征，它的数值相差很大的话，那么那个比较大的特征值就会占用更大的权重，然后你的那个机器学习模型就会更加倾向于去调整那个更大的权重，而不是然后会忽略那个比较小的权重。所以这就是为什么我们必须要做 normalization， 在那个 data processing 的 step 的时候就要做 normalization， 然后再把那个数据传给 machine learning model。So it means we need to treat all the features fairly, okay? Yeah, so this is a point. And then for some more complicated example, we don't only have like one minimum or maximum value. We have several values here. So for example, if we are calculating the first derivatives of this function, then the result will be like 4, okay? So fx. Let me try again with this pen. Fx equal to 4. 4x cubed. Okay. I give up. 4x cubed plus 3x squared minus 6x minus 2, right? If I made some mistakes, please correct me, okay? 4x3, 3x2 minus 6x minus 2, yeah. So if we want to find the minimum and maximum point of this function, we need to calculate the root of this function to be 0, right? And because it's a cubic function, so we will have 3 different roots. And because, for example, here we have 2 different minimum point here. And this is the problem here. The machine learning model is not able to find out which is the global minimum, the real minimum point, and which is the local minimum. So it's like the minimum point in a local range. And also like for the local maximum, we can see that we have we have bigger value here. So this maximum point is actually a local maximum. And this minimum point here is a local minimum. The real minimum point is here. Yeah, so this is another point in the machine learning problems that we need to solve. But yeah, later we will introduce some technology to solve this kind of problem, like SGD, like stochastic gradient descent, that you will learn later. So we will initialize different points of values here, and then it will do gradient descent together to find the optimal point in this curve. Yeah, so this is also about the optimization. Some mathematical things, but you just need to know like how you calculate the roots. I mean, the first derivatives, the second derivative, to check like how many minimum or maximum points we have, and then what are they. So this is what all you need to do. And for the real application in the machine learning, you don't need to do anything about the mathematics in machine learning. You just use some functions or libraries. Yeah, so this is the end of these slides. And then we can have a look at some questions that might relate it to your quizzes or final, the final exam. So yeah, this tutorial. Okay. And let me first upload this tutorial to the OLE. So previously our lab have 2 hours, but this term we only have 1 hour lab. So that's why we are not able to talking about tutorial in the lab. And that's why I plan to talk about some of the tutorials if we have time during the lecture, because these tutorials are quite related to your quizzes and your final exam. But yeah, no worries, we will upload the answers and the tutorial on the OLE later. So the question sheet I've already uploaded to the LE. You can download it if you want. So let's first talk about the first one. Like it asks you to name some major problems in machine learning. So this is what we learned in the first lecture. Where's the website? See? Just using the OLUSD. Oh, sorry. I also need to upload in another. I only upload in the one OLE because we have two courses here. So let me also upload to the 3920 course. Okay. Then let's have a look at the first lecture. This is about, yeah, so the 4 kinds of machine learning problems that we have is classification, regression, recommendation, and imputation. Okay, so classification is just to classify different categories, help you to classify different categories, like if an image is a dog or a cat, so it's called classification. Regression is to predict some values, some numerical values, like the weather, the temperature, not weather. Weather is actually, yeah, if you're already talking about like raining, sunny, it's actually still a classification problem. But if you're talking about the temperature, you're predicting the temperature, then it's a kind of regression problem. And yeah, also recommendation. So it's like when you are doing some online shopping, it will associate some items to the items you are buying. So this is called recommendation. According to your behavior and the things you buy, it will recommend something related to the item you buy or the things you like. And also imputation, that we've talked about this in this lecture, that is just to infer the value of some input data. So this is the 4 problems we have in the machine learning, okay? And then the second one is to name the 5 major steps in the machine learning workflow. Okay, so let's have a look at the workflow. Machine learning workflow should be here. So this is also from the first lab about machine learning workflow. So we have data collection and preparation at the beginning. After we got the data, we are doing modeling. And in this modeling, we have 3 steps. One is the model building. The second is the model evaluation. The third is the model optimization. And after modeling, we are doing prediction. So this is the last step is predictions on the new data. So yeah, these are the answers for the second question in the tutorial. So simply, we can just say data collection, model building, evaluation, optimization, and prediction. So these are the 5 steps. And then the third one is, okay, it's an open question. Suppose a supermarket would like to improve its sales using machine learning. What kind of data do you suggest to collect? So anyone have some ideas? And yeah, because this is open question, and when you make this kind of questions in your quizzes or exam, you can just write anything you like, but just justify them, justify your answers, okay? But you should be logical. Don't write something that not relevant to the topic. So for example, in this topic, you can collect data like what kind of the goods the customer is buying every day, like in which period customer prefer to buy what kind of things, and also like the location of the goods in the supermarket. Because if you put them in a very obvious place, like in the front, I mean, just close to the entrance, then it will be exposed to more customers, and then it will might have better sales. And if we put them in a very in a place that not able to discover for the customer, then this kind of goods might have less sales. Okay, so this is another example. And also you can have some statistics about the peaks of the amount of customer during the day or during the night. I mean, to see like the amount of customer in each period, and then to help you to make a better decision, how you arrange your working hours or how you arrange your promotions or kind of activities. Yeah, so this is just some examples. You can write anything related to this topic, but just justify your reasons. And then it's about, yeah, the Titanic. This is from the second lecture that we've talked about this class. So this is about the Titanic survival. And it asks you to explain why the following features should not be included in the prediction. Okay, so just have a look at it, and yeah, I will give you like a while to think about it. Yeah, just look at the features and think about which one is more important and which one might be useless, and then you can exclude them from the features to train the model. Okay, then let's have a discussion on it. So, because we are predict the survival on the Titanic, so of course, the column of survival should be the target. Okay, so like it to check if the passenger is survived or not. So this should be the target that we want to predict. And then we have some other features here used to predict these targets. So of course, like the P class, the passenger class, that you sometimes you have first class, second class, and third class. And the higher class you are in, you might have better environment in the cabin, that you might also have priority to get kind of services, and yeah, you will maybe stay in a more safer, in safer places, so you will have higher survival rate. So this is could be an important feature that we want to use. And then name of the customer, of course, useless. It's not like you change your name, then you can survive, right? But like in some, in the history, like in China, right? Sometimes some people think name is very related to your luck. So yeah, but in a scientific way, name has no relation to your survival rate, okay? And also the gender here, this might be another feature that we want to use, because you know that ladies first, right? So every time if you want to get rescued, usually the ladies will get rescued first, and then the man will wait until all the ladies has been rescued. So the gender might also be an important features here. And the age, yeah, age might also be a more important feature because younger people might be, how to say, more energetic. So they might have higher possibility to be survived during these accidents, and older people, they might not. And also like very young people, small kid, they will have superiority to be rescued. So age is also an important factor here. And then like the number of siblings and spouses. So yeah, it's actually hard to see. I mean, hard to say. So yeah, maybe you have some brothers together with you to getting aboard on the ship, and then they will help you to make you survive. So this is a kind of possibility, but you can't see anything on it just to justify it. And also number of parents, children abroad. Yeah, also the same thing as this one. These two are similar, just to justify them, no matter if you think they are important or not. And the ticket number. So the ticket number may be related to the P classes. Not sure, but yeah, it's not a very important thing. And the fare, yeah, because if you buy first class ticket, then you need to pay more fare, right? So this is highly correlated with this P class. So this might also be an important feature. The cabin doesn't matter, I think. It's also related to the P classes and the fare. So these three features are highly correlated. 具有较高的相关性。然后so yeah, I think you can discard it or use it, doesn't matter. So just justify your reason. And then here's the port of embarkation, like which port you use to get on the ship. So I think it's useless, right? It doesn't matter where you get on the Titanic, if you can survive or not. So this is also a useless feature that you can exclude from the data set. Okay, so this is also an open question. And then let's have a look at this part here. So this is about calculation. Do we still have time? Yeah, so I don't know if we can write here, but oh, we can write here. Oh, this looks good. Oh no, you guys. Okay. So if we cannot write here, I'll just directly show you the answers. To the solutions. Okay, this solution I will upload to the OLE later. Okay. So we can see, firstly, we need to firstly calculate the first derivatives of this function. And then we calculate the root of these first derivatives of this function to see how many maximum or minimum values we have. So because this is a squared function, so we should have two roots. One is this one, the second one is -6, one is 1 divided by 6. Yeah, okay, so then we calculate the second derivatives of this original function. We got another formula here. Then we just put these two roots inside its second derivative to calculate the value of the second derivatives in each point. And then if this positive value, then it means this is a minimum point. If it's a negative value, then it means it is a maximum point. So yeah, very simple, right? Very similar with what we are doing in your math classes. This is about the finding, about the optimization problem to find the minimum and maximum point of a certain function. Okay, so this is the end of class. And if you have any questions, please just text me. If you have questions regarding the tutorial or lectures, doesn't matter, just send me a message and we can discuss. Okay, thank you very much for today and see you next week. Actually, some of you might be tomorrow, right? Okay, see you.